Hi friends, today's topic is direct coupling and transformer coupling. So in the last video we discussed about the multi-stage amplifier and also RC coupled multi-stage amplifier. So in this video we discuss about the direct coupling and also transformer coupling. So this is the circuit. So this circuit is the example for the direct coupling amplifier. So this is the direct coupling 3-stage amplifier because it contains 3 transistors or 3 amplifiers. So in this circuit, here there is no coupling devices is applied. You can see here there is no coupling devices such as resistors, capacitors and transformers cannot be used to couple the two amplifiers. So here we use directly first stage to second stage. So this is the first stage. This is the first stage. So here in this first stage the output will appear at this point, means collector point of the transistor T1. So this output is directly fed to the input of the second transistor T2. And also the output is appears at the collector of the transistor T2 here. So this output is directly fed to the input of the transistor T3. Okay. So this circuit is used only in low frequency amplification and low current amplification here. For low current amplification, here for example phototransistor current and thermocouple current. So in this we have used for the here we use direct coupled amplifier for the amplification. Next, here the variations of the first transistor is cancelled in the second transistor. So here the first transistor is the NPN transistor and transistor T2 is the PNP transistor. The variation like for example IC or beta. So here IC can be changed in the, so how much the beta will be changed in the T1, so that amount of the beta will be cancelled in the T2. So this is about the direct coupling multi-stage amplifier. Okay, so uses of this circuit. So I already tell that low frequency amplification and low current amplification. And this circuit is very simple. So here we use less number of resistors and less number of transistors. There is no use capacitors and transformer like that components. So that's why. So this circuit is very simple and also low cost. But this circuit cannot be used for the high frequency and high current. Next, transformer coupling. So this is the circuit of the transformer coupling. So this circuit have 2 stages. So this is 2-stage transformer coupled amplifier. So this is one stage and this is one stage. So in this circuit we have used the voltage divider biasing for the proper operating point and stabilize. So voltage divisor biasing circuit gives very high stability to the transistor. So next, here we use Cin for the coupling the signal, means input to the first stage of the transistor T. Okay, so here we use Cin. So I already tell that Cin or CC coupling capacitors or C-in blocks the DC and allows the AC signal. We have used, so this CE is called the bypass capacitor. So I already tell the working of the bypass capacitors and also coupling capacitors in the RC coupled amplifier. So this bypass capacitor bypass the AC signal. Next, here we use the transformer to couple the two stages or connect the two stages. So that's why it's called transformer coupling. Here the transformer T1 is connected at the output part of the first stage amplifier. So here IC means collector current is directly connected to the or passing through the primary coil of the transformer. So here the instead of means RC means collector resistor, in that position we use transformer. Next, the secondary winds is connected to the input of the second stage of the transistor means amplifier. So here in the secondary coil we get the output. So this output is the mainly depends on the secondary winds ratio or transformer winding ratio of the transformer and also transistor. So next here, so it is the connection. So one terminal of the secondary coil is connected to the VDB circuit R1 and R2, and in another terminal is connected directly to the base terminal of the second stage transistor or second stage amplifier. Okay, next here there is another transformer is present at the second stage. So in this stage we get the output at the transformer secondary coil. So in this case, so in this position we get the output. Next, so this is the transformer coupling. Next, so the frequency response. Next, frequency response. So it is a graph between frequency and the voltage gain. So your voltage gain along the y-axis, frequency along the x-axis. So here when the frequency is increases, the voltage is also, output voltage is also increases or gain is also increases. The gain is mainly depends on the output voltage. So here output voltage V out is depends on the IC collector current and also XL impedance of the inductor of the primary coil. So here XL impedance, XL is directly proportional to frequency or 2 pi f L. So here at lower frequency, the gain will be increases because f is very low. So f is very low, XL is also low. So reactance will be low. Reactance nothing but impedance will be low. The output voltage is the product of the IC and the XL or impedance. So here XL is low, the output voltage is also low. So F is increases, XL is also increases because directly proportional. So when an XL is increases, the output voltage V out is also increases. So output voltage increases, gain is also increases. And certain frequency, it becomes constant and continues its saturation point. So this is the frequency response of the transformer coupled multi-stage amplifier. The uses of the transformer coupled amplifier is the first one. The first one is an excellent impedance matching is provided. So this impedance matching is excellent in the case of the transformer coupled amplifier, but it is very poor in the RC coupled amplifier. So in the RC coupled amplifier, the output impedance is very high. Of output impedance of the first stage is very high. The input impedance of the second stage is very low. So that's why the effective resistance is very low. So it is the major drawback in the RC coupled amplifier. But in the case of transformer coupled amplifier, so it is overcome in the transformer coupled amplifier. So this is the major advantage. Next, gain achieved is higher. So comparing the RC coupled amplifier, the gain is very high in the transformer coupled amplifier. There will be no power loss in collector and base resistors. So power loss is very less and efficient in operation. So this is very efficient in operation, and so these type of coupling amplifier means transformer coupling amplifier can be used in a power amplification. So this is the use of the, and this is the working of the transformer coupling amplifier and also direct coupling amplifier. Okay, so next class we discuss another important topic. So thank you.